In this video, I'll explain the concept of correlation. Suppose you have data which is available for two variables, say x and y, then we call that data as bivariate distribution because there are more than one variable in the given data. For example, time spent on study and marks obtained by students in exam. So if you want to collect the data on this, then there are two variables. One is time spent on study and another variable is marks obtained by the student. So this kind of data is called as bivariate data because there are two variables. Now, if you would like to find out the relationship between these two variables, in particular the linear relationship between these two variables, then we need a concept called as correlation. That is, whether marks increases or decreases as time spent on study increases or decreases. So if there is any relationship between one variable and the another, then it is called as correlation. Correlation is all about finding the linear relationship between the given two variables. So when two variables are related in such a way that change in the value of one variable affects the value of another variable, then those variables are said to be correlated, or there is correlation between those two variables. So see here, time spent on study, if it increases, you have to check whether marks obtained by the students increases, or time spent on study, if it decreases, what happens to the marks obtained by the students. If you are studying that, you are checking are those two variables related in any way. Now let's see what are different types of correlation. So according to the direction of change in variables, there are two types. As there are two variables, if one variable affects the other variable, that is change in one variable affects the other variable, then we can name one variable as dependent variable and another as independent variable. So according to the direction of change, how the dependent variable changes when independent variable change. So based on that, there are two types of correlation. One is positive correlation. So in positive correlation, values of the variables deviate in the same direction. That means if the values of one variable increases, then the values of other variable also increases. If values of one variable decreases, then the values of other variable also decreases. That means they are moving in the same direction. If the value of the independent variable increases, dependent variable also increases. If the value of the independent variable decreases, then dependent variable also decreases. Such correlation is called as positive correlation. See, for example, amount of rainfall and yield of crops. If the rainfall increases, then yield of crops also increases. If rainfall decreases, yield of crops also decreases. This is one example for positive correlation. Negative correlation means here values of the variable deviate in opposite direction. That means if the independent variable increases, the dependent variable decreases, and vice versa. For example, volume and pressure of perfect gas. If the volume increases, then clearly pressure decreases. If the volume decreases, then pressure on that perfect gas increases. So price and demand of goods. If price increases, demand decreases. If price decreases, then definitely there is an increase in the demand of goods. So this kind of correlation is called as a negative correlation. Now, here's the concept of scatter diagram. You can use scatter diagram to represent the data and to check whether the given data correlated or not. So, it's a statistical tool for determining the potentiality of correlation between dependent and independent variables. And if that correlation is perfect positive, then you will get a straight line. The data points are aligned along the straight line. Perfect negative correlation means this is also straight line, but it is in the decreasing way. That is, from left to right, it decreases. As the values of the data point increases, the values here decreases. Dependent variable values decreases. So it is perfect negative correlation. So positive correlation means data points are spread in this way, but you can always draw a line, and these data points are besides the given line, they are not far away from the line. So all these data points look like they are increasing in the increasing order. Similarly, negative correlation means here also data points can be aligned along the straight line this way, and the points are beside the straight line, but negative because here the data points are decreasing, the dependent variable value decreases as the independent variable value increases. This kind of data is called as uncorrelated data because data points are spread randomly here. So this kind of data is called as uncorrelated data. Now, the scatter diagram just tells you the potentiality of the correlation between the two variables. If you want to measure the intensity or degree of relationship between the two variables, then we use coefficient of correlation. Suppose if x and y are two random variables, then correlation coefficient, which is called as Karl-Pearson's correlation coefficient, is given by r equal to covariance of x comma y by square root of v of x into v of y. V means variance of x and variance of the next series, that is y. There are two random variables x and y, two series of data x and y with the observations x1 x2 so on up to xn. Here the observations y1 y2 so on up to yn. So this is the formula to get the correlation coefficient. So correlation coefficient of x comma y, when you substitute the formula for covariance of x comma y, we have 1 by n at summation I equal to 1 to n xi minus x bar into yi minus y bar divided by square root of, to find the variance of the first series x, we have 1 by n into summation I equal to 1 to n xi minus x bar whole square. Similarly for the second series, where x bar is the mean of the first series and y bar is the mean of the second series. So when you simplify this, you will get r equal to summation I equal to 1 to n into xi minus x bar into yi minus y bar divided by square root of summation I equal to 1 to n xi minus x bar whole square into summation I equal to 1 to n yi minus y bar whole square. So this is the final formula to find out correlation coefficient, and this is called as Karl-Pearson's correlation coefficient. This measures the intensity of relationship between the two variables. And this correlation coefficient is simple correlation coefficient because we are just having two variables x and y, and we are measuring the linear relationship between the two variables x and y. Now, some properties of correlation coefficient, that is based on the value of r, you have to remember few of the facts. R value always lies between -1 and 1. So if r equal to 1, then we can say that there is perfect positive correlation between the two variables. If r equal to -1, there is perfect negative correlation. That means if the value of independent variable increases, the value of dependent variable decreases, and vice versa. R equal to 0 means there is no correlation. If you obtain r equal to 0 for any two variables, then we say that they are uncorrelated data. R is in between 0 to 0.25, then there is a weak positive correlation. R is in between 0.75 to 1, there is a strong positive correlation. R is in between -0.25 and 0, there is weak negative correlation. If R is in between -0.75 to -1, then that is strong negative correlation. These facts you have to remember before solving the problems. So here is one problem. Find the correlation coefficient between advertisement expenditure and profit for the following data. That means these are the two variables. One is advertisement expenditure and another variable is profit. You have to find out, is there any relationship between these two variables. That means if this increases, expenditure increases, what happens to the profit, whether it increases or decreases, and what is the intensity of their relationship, that we have to find out. So first let us find out, let us write the formula for correlation coefficient, that Karl-Pearson's formula for correlation coefficient, summation I equal to 1 to n. Here we have xi minus x bar into yi minus y bar divided by square root of summation I equal to 1 to n xi minus x bar whole square into summation I equal to 1 to n yi minus y bar whole square. This is the formula to calculate the correlation coefficient. Now, from this formula, we want to find out x bar, that is mean of first series, y bar, mean of the second series. So, let us do that one by one. So, first, let us write the data in tabular form. So, first is x variable and another variable is y, that is profit is y, and advertisement expenditure, it is, I'll name it as x. So here we have the values 30, 44, 45, 43, 34 and 44. And here 56, 55, 60, 64, 62, 63. Now the first series data, it is a discrete data here because single data points are given here. So how to find the mean of the discrete data? Sum of observations by total number of observations. That is, we have to add all these, divide by 6. There are 6 observations. So here 30 plus 44 plus 45 plus 43 plus 34 plus 44 whole divided by, there are 6 observations, so divided by 6. So we will get x bar as, so here we have to add all these data. So 4 plus 4, 8, 11, 16 and 22. Then we have 4 4 is 16, 19, then 22, 24, 240. So it is 240 divided by 6. X bar equal to 40. So mean of the first series is 40. Similarly, y bar, mean of the second data set. So here we have to add all these values divided by number of observations. You will have the sum as 360 here. So here it is 6 plus 3, 9, 14 plus 6, 20, 2 is the carry, 6 was the 24 plus 10, 34 plus 2, 36. So 36 by 6 gives you 60. So y bar equal to 60. Once you get the mean of the two series, then I want xi minus x bar, yi minus y bar, then xi minus x bar square, yi minus y bar square. This is easy. Then their sum. So xi minus x bar means subtract mean from each observation. So first series mean is a 40. So 30 minus 40 minus 10. Then 44 minus 44. 45 minus 40. 5, 43 minus 43, 34 minus 40 minus 6, 44 minus 44. Similarly, yi minus y bar is 60, 56 minus 60 minus 4, 55 minus 60 minus 5, 60 minus 60 0, 64 minus 64, 62 minus 62, 3 here. Then their square 100, this is 10 minus 10 square 100, 4 square 16, 25, 9, 36, 16. Here 16, 25, 0, 16, 4 and 9. Now I need sum of all this because I want one more xi minus x bar into yi minus y bar. So product of these two, minus 10 minus 4, 40, then minus 20, then 5 zeros is 0, 4 3 is 12, then 4 3 is 12 minus 12, then 4 3 is a plus 12. So anyway, this minus 12 plus 12 becomes 0. Then we have minus 20 plus 12 gives you minus 8. 40 minus 8 gives you 32 here. Then this is summation of xi into xi minus x bar into yi minus y bar. Then here I need this sum as well. So that is 29, or else you can do 6 plus 4, 10, 9, 19, 24 and 30. 3 is the carry, 4, 7, 70 it is. Then this sum, it is 11, 20, 26, 32. 3 is the carry. 3 plus 1, 4, 5, 6. Then 9, 10. So, and 2 not 2 it is. In this case, Yes, I just want the sum of these three. Now I have to substitute all this in the formula. R equal to summation of this is 32 divided by square root of summation of xi minus x bar whole square is 202 into summation of yi minus y bar whole square is 70. So when you simplify all this, R value comes out to be 0.27. So based on this value of R is positive. That means there is a positive correlation between advertisement expenditure and profit. That means if advertisement expenditure increases, profit also increases. Now, as R is very close to 0.25, hence there is a weak positive correlation between these two variables. Though it is positive correlation, as one increases, the other one also increases. The value of R is 0.27. There is a weak positive correlation between advertised expenditure and profit. Now you can have one more way of finding correlation coefficient without using the mean. You can see that in the previous example, mean of x and y, both the series were whole numbers, so calculation was easy. When the mean is not a full number, when it has a fractional part also, so in that case you can avoid the previous formula and we can restate the formula in terms of data values as r equal to n into summation xi yi I equal to 1 to n minus summation I equal to 1 to n xi into summation I equal to 1 to n yi divided by square root of n into summation of xi square minus summation of xi whole square into n into summation of yi square minus summation of yi whole square. So this formula is used to find out the correlation coefficient. This formula avoids finding the mean of the data set. Without using the mean, we are finding the correlation coefficient using just the data values. I hope you understood the concept. Thank you for watching.